Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first 4 parts of time, speed and distance where I have explained the basic concepts of time, speed and distance, average speed, relative speed and boats and streams. I have also explained some word problems based on these concepts. So if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to learn the concept of races and circular tracks. And in the next video, we'll be doing some word problems based on these concepts. So let us start with today's video. In races and circular tracks, we are going to use the same formula, that is distance is equal to speed into time. But to use that, we need to know the concept of races and circular tracks. So let us start with the concept of races first. Suppose A and B are two friends and they are running a race from point X to point Y, where X is the starting point and Y is the finishing point of the race. Let us assume that this race is of 100-meter length. Now, it is possible that both of them, that is A and B, starts from the starting point and they travel 100 meters to win the race with their own speeds. But it is also possible that one of them starts a little later than the other. For example, say if it has been given that A gives B a start of 10 meters, say. That means B will be 10 meters ahead of the starting point. So B will have to travel 100 minus 10, that is 90 meters to win the race, whereas A will have to travel the complete 100 meters to win the race. In a similar way, it can be given that A gives B a start of 5 seconds, say. So that means B will be 5 seconds ahead of the starting point, whereas A will be again starting from the starting point. Now, it can be also given that A beats B by 20 meters or 10 seconds. So this simply means that for a 100-meter race, when A would be completing 100 meters, in that particular time, B would be completing 100 minus 20, that is 80 meters. Or when A would be completing this 100-meter race, B would be taking another 10 seconds to complete the race. In other words, we can also say that B travels this 20 meters in 10 seconds. So we can say that the speed of B in this particular case would be simply 20 by 10, that is 2 meters per second. So now, if we want to generalize this, we can say that in a L meter race, if A gives B a start of X meters, in that case, A has to travel L meters, whereas B has to travel L minus X meters to win the race. In a similar way, when we say that A beats B by X meters or T seconds, in that case, when A has traveled L meters or when A has completed the race, in that particular time, B has covered L minus X meters, or B has to travel another T seconds to complete the race. Now, let us see the concept of circular tracks. Suppose I have a circular track of length 100 meters and say this is the starting point. There are two persons, A and B, and they are traveling in the same direction. A with a speed of 30 meters per second and B with a speed of 10 meters per second in the same direction, that is in the clockwise direction. Now, in circular tracks, basically there are two things in which we're interested. First is the time after which they will meet for the first time, and second, time after which they will meet at the starting point. Now, A is traveling with a speed of 30 meters per second and B is traveling with a speed of 10 meters per second. So the ratio of the speeds of A and B would be simply 3:1. So that means when A covers 3 part of the distance in the same time, B would be covering 1 part of the distance. So that means if A and B starts from the starting point at the same time, then if B covers 1 part of the distance, that is if B is at this point, then A would be covering 3 part, that is 1, 2 and 3. So that means A would be at this point. In a similar way, when B would be covering another 1 part, that means when B would be here, then A would be covering 3 part, that is 1, 2 and 3. So can we say that this would be the first meeting point, and I'm denoting it with M1, that is the first meeting point. So in this first meeting point, I can see that B covers half of the circular track, whereas A has covered 1.5, that is 3/2 of the circular track. Again, when B would be covering 1 part of the distance, that is when B would be here, in that case, A would be covering 3 part, that is 1, 2 and 3 part here. Then again, B would be covering 1 part of the distance, then A would be covering 3 part, that is 1, 2 and 3 part. So can we say that this would be the second meeting point, that is the starting point would be the second meeting point of A and B. Now again, to meet for the second time, A has completed 1 complete round more than B. So now when B has completed 1 complete round, in that case, A has completed 3 complete rounds. That means from one meeting point to the next meeting point, the faster person, that is A in this case, will cover 1 complete round more than the slower person, that is B. Now, if we continue in a similar way, we can say that they'll be meeting here for the third time, and they'll be meeting here for the fourth time, and so on. So that means there will be only 2 meeting points for this particular case, which would be alternate and would be diametrically opposite to each other. In fact, there is a shorter way by which we can find the total number of meeting points when the persons are traveling in the same direction or opposite direction in case of circular track. So here, the ratio of the speed of A and B is 3:1. So the difference of their ratio of speeds would be 3 minus 1, that is 2. So there would be only 2 meeting points. Suppose in case if A would have traveled with a speed of say 30 meters per second, and say B would have traveled with a speed of say 20 meters per second, then the ratio of their speeds would be 3:2. So the number of meeting points when they would be traveling in the same direction would be simply 3 minus 2, that is 1, and that would be the starting point. Now, if we try to find the time for the first meeting point and the time after which they will be meeting at the starting point, in that case, we can say they would be covering a distance of 100 meters with a relative speed of 30 minus 10, that is 20 meters per second, as they are traveling in the same direction. So the time to meet for the first time would be simply 100 upon 20, that is 5 seconds. So that means every 5 seconds they would be meeting. So after 5 seconds, they are meeting at this point. So we can say that after 5 seconds, they will be at the starting point. So that means after 10 seconds, they would be meeting at the starting point. There is one more way to calculate the time to meet at the starting point. Now, if we consider for A, the time taken by A to reach the starting point again would be simply distance upon time, that is 100 upon 30. So that would be 10/3 seconds. So after every 10/3 seconds, A would be at the starting point. In a similar way, the time taken by B to be at the starting point would be simply 100 upon 10, that is 10 seconds. So after every 10 seconds, B would be at the starting point. So now if we take the LCM of this 2 times, we can say that after every 10 seconds, they will be meeting at the starting point. So there are 2 ways by which we can find the time to meet at the starting point. First is simply find the time to meet for the first time. and multiply it with the number of meeting points, and the other is simply find the individual person's time to reach at the starting point and then take the LCM to find the time for their meeting point at the starting point. So the time after which they will meet for the first time can be simply find out by dividing the total circular length by the relative speed of the two persons, and the time after which they will be meeting at the starting point can be find out simply by multiplying the total number of meeting points with the first meeting point, or can be found out simply by taking the LCM of the time taken by each person to complete the circular track. So now let us consider the same example, but in this case, let us assume that A is traveling in the clockwise direction and B is traveling in the anti-clockwise direction. A is again traveling with a speed of 30 meters per second and B is traveling with a speed of 10 meters per second. And we are again interested in these two things, that is the time taken to meet for the first time and the time taken to meet at the starting point for the first time. So here again, the ratio of the speeds of A and B would be 3:1. So when A travels 3 parts of the distance in the same time, B would be traveling 1 part of the distance. So when A would be traveling 1, 2, 3 part of the distance, B would be traveling 1 part of the distance. So we can say that this would be the first meeting point. Again, A would continue to travel in the clockwise direction. So A would be traveling 3 parts, that is 1, 2, and 3. And B would be traveling in the anti-clockwise direction. So B would be here. So this would be the second meeting point. In a similar way, A would be traveling 3 parts. So 1, 2, and 3. And B would be traveling in the anti-clockwise direction for 1 part. So this would be the third meeting point. And A would be again traveling 3 parts in the clockwise direction. So 1, 2, and 3, and B would be traveling 1 part in the anti-clockwise direction. So B would be here. So this would be the fourth meeting point, that is at the starting point. Now, if we continue, we'll be getting only these 4 meeting points. So just like when the persons were traveling in the same direction, we can also find the number of meeting points in the opposite direction, which would be simply the sum of the ratio of the speeds of A and B. So in this case, the ratio of the speeds of A and B is 3:1. So the number of meeting points would be simply 3 plus 1, that is 4 meeting points. And these meeting points would be symmetrical to each other. Again, suppose if the speed of A was say 30 meters per second and the speed of B was say 20 meters per second, and say they were traveling in the opposite direction, then the ratio of the speeds of A and B would be 3:2. So the number of meeting points in this case would have been 3 plus 2, that is 5 meeting points. And again, these 5 meeting points would have been symmetrical to each other, that is would have been at 20 meters distance to each other if the total circular track would have been 100 meters of length. So the time taken to meet for the first time in this case would be simply the circular track length, which would be 100, upon the sum of the relative speed as they are traveling in opposite directions. So this would be 30 plus 10. So 100 upon 40, so which will give us 2.5 seconds. So that means after every 2.5 seconds, they would be meeting. So when will they meet at the starting point? So this would be simply 2.5 seconds times the number of meeting points, which in this case would be 4. So this would be 10 seconds. So that means after every 10 seconds, they will be meeting at the starting point. Now, just like in the previous case, that is when they were traveling in the same direction, we can also find the time taken to meet at the starting point simply by taking the LCM of the time for each person to complete the track individually. So the time taken by A to complete the track would be simply 100 upon 30 seconds, which would be 10 by 3 seconds. And the time taken by B to complete this track would be 100 upon 10, that is 10 seconds. So the LCM of this two time would be again 10 seconds. So that means they'll be meeting at the starting point after every 10 seconds. So the time taken to meet for the first time would be simply the length of the track upon the relative speed, which would be the sum of the speeds. And the time taken to meet at the starting point can be simply found out by the time taken to meet for the first time times the number of meeting points, or can be simply found out by taking the LCM of the time taken by each person to complete the track individually. Also, one thing we can note here is from one meeting point to the next meeting point, these two persons, that is A and B, would be together covering a distance which would be equal to the length of the track. That is, together they would be covering a distance of 100 meters from one meeting point to the next meeting point. Now, let us consider this case when three persons are traveling in the same direction and we need to find the time to meet for the first time and the time to meet at the starting point for this three person. Here I have considered A is traveling with a speed of 40 meters per second, B is traveling with a speed of 30 meters per second, and C is traveling with a speed of 10 meters per second. And all these persons are traveling in the same direction, that is in the clockwise direction in this case. Now, to find the time for all of these persons to meet for the first time and to meet at the starting point, let us consider first the time for A and B to meet for the first time. So for A and B to meet for the first time, this would be simply 100 upon 40 minus 30, as they are traveling in the same direction. So this would be 10 seconds. In a similar way, if we consider for B and C to meet for the first time, this would be 100 upon 30 minus 10, which would be 5 seconds. So that means A and B would be meeting after every 10 seconds and B and C would be meeting after every 5 seconds. Also, we know that A and B has speed of 40 and 30 meters per second. So they'll be meeting at 4 minus 3, that is at only one point, which would be the starting point. In a similar way, B and C has speeds of 30 and 10. So they would be meeting at 3 minus 1, that is 2 points, which would be the starting point and the point which would be diametrically opposite. So the time taken for all A, B, and C to meet for the first time would be simply LCM of 10 and 5, which would be 10 seconds. Also, this 10 seconds would be the time to meet all of these three persons at the starting point, as A and B meet only at this point and B and C meet at this point and a point which is diametrically opposite to this point. So this 10 seconds would be the time to meet for the first time, and also this would be the time to meet at the starting point. Also, we can find the time for this three person to meet at the starting point simply by taking the LCM of the time taken by each person to complete this track individually. In this case, the time taken by A to complete this track would be 100 by 40, which would be 2.5 seconds. The time taken by B to complete this 100 meters track would be 100 upon 30, which would be 10 by 3 seconds. And the time taken by C to complete this 100-meter track would be 100 upon 10, that is 10 seconds. Now, if we take the LCM of these three numbers, that is 2.5, 10 by 3, and 10, this LCM would be simply 10 seconds. Now, in this case, we have considered all these three persons are running in the same direction. But there can be some cases where two of them are running in one direction and the third person are running in the opposite direction. In such cases also, we can use this same logic and we can find the time to meet for the first time and the time to meet at the starting point for the first time. So if we summarize all the points that we have learned, we can say that if A and B are two persons traveling with speeds of small a and small b, where A is greater than B, and they are running in a circular track of length L, starting at the same point and at the same time, in that case, the time taken to meet for the first time when they are traveling in the same direction would be given by L upon A minus B, and when they are traveling in the opposite direction, it would be given by L upon A plus B. And the time taken to meet at the starting point would be the LCM of L by A and L by B. And when they are traveling in opposite direction, this time would be LCM of L by A and L by B. In a similar way, if I have three persons traveling in the same direction with speeds of small a, small b, and small c, in that case, the time taken to meet for the first time would be the LCM of L upon A minus B and L upon B minus C. And the time taken to meet at the starting point would be the LCM of L by A, L by B, and L by C. Also, we can find the number of meeting points when persons are traveling in the same direction and in opposite direction. So when the persons are traveling in the same direction, then the number of meeting points would be simply A minus B, and when the persons are traveling in the opposite direction, then the number of meeting point would be A plus B, where small a and small b are the ratio of the speeds of the person A and B respectively. Also, the time taken to meet at starting point can also be found out by taking the help of the number of meeting points, which would be simply the time taken to meet for the first time times the number of meeting points. So that's it for today's video, in which we have learned the concepts of races and circular tracks. You may find these concepts a bit confusing if you're learning it for the first time, but I would request you to watch the video again and try to understand these concepts instead of just by-hearting the formulas. Also, in the next video, we are going to do some word problems on these concepts. So I hope you'll be more confident on this topic post that video. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.